subject of my talk today is TAIBOM, and what I'm trying to get across to you today is a set of technologies that we believe are foundational to any attempt to build up secure AI, safe AI, however you want to call it. So TAIBOM, I'm sort of regretting calling it trustworthy AI. I think it really should be trustable AI bill of materials, because there's nothing inherent in what I'm going to talk about that ensures that it's trustworthy, but it does lay the foundation for you to make the assessment of whether something is trustworthy or not. So to do this, I've got a load of slides, probably more slides I can do in 20 minutes. I'll try and get across something to do with the AI security landscape. And then I'm going to focus a lot on what I call the foundational considerations, because we set ourselves something of a challenge here in that we're trying to develop and sell a concept called TAIBOM, where, to be honest, at the moment in the UK, people haven't really caught up with SBOM yet. So we're sort of a bit ahead of ourselves. So I'm going to try and really get across to you why we think these sort of like foundational concepts are so important. I'll talk a little bit about the use cases and the individual building blocks and next steps. But also feel free as well to, if you've got any burning questions, to interrupt me as I go along. So, AI security. There's a lot of opinions out there. There's a lot of different bodies, organisations, companies, standards organisations. The top 7 is just the UK government itself, I think, with separate organisations, each of which is, claiming that they've got a role to play and is offering you some guidance of what it means to be secure, safe, trustable, responsible AI, however you want to define it. What I hope to persuade you is, no matter which of these you look at, or the flavour of the month, the underlying primitives of TAIBOM have a role to play. And this is a tiny snapshot. The full number of organisations sort of like operating in this area is just absolutely huge. Looking at things through a different lens, if you want to look at the more research aspect of secure, safe AI, there's lots of different techniques that are up in the air at the moment. Some of them will work together, some of them will play against each other. I don't know which one will win. They're all doing something intelligent and sensible. But again, I think what we're proposing in TAIBOM has a role to play in each and every one of those, because it doesn't matter what standard you adhere to or what technique. One of the things we're trying to address in TAIBOM is the identity problem of pointing to something and saying this is the thing that it applies to. And as I'll try and get across to you later on, without that, everything else is anchorless. So what is it? TAIBOM. I think we'll look at it through a number of different lenses. But the first, I suppose, is basically it's a way of evaluating the inherent risk in the system, without necessarily saying which particular dimension of risk, but underpinning the BOM piece is the risk of the whole. If you want to decompose it, it's got to be made up of the risk of the parts. And what we'll look at is, well, why is the parts of an AI system different to a normal software system? And we'll also look at and how do we aggregate the notion of risk over these different components. So this is one way of understanding what TAIBOM is all about. So another definition, working definition, is essentially it's the description of the AI system and its dependencies at a level sufficient to meaningfully infer risk. Now, this is quite different to, as we'll see later, describing a thing of its parts enough to build something. That's like a makefile. That's not what the BOM piece is about. The BOM piece, in terms of how it's practically used and how SBOMs are used, as we'll see in the use cases later, it's assimilating the risk from the various components of the system. Oh yeah, this is what computer scientists call a joke. So the 2 hard things in computer science: cache and validation, naming things, and I missed the bit out. Errors +1. Anyway, the key point about this is TAIBOM really covers both of those aspects. The 2 of the big challenges that we're dealing with are the naming things problem, and I'll go into that in a little bit of detail, and cache invalidation, because essentially the underpinnings of TAIBOM is largely sort of digital certificates and verifiable credentials. Essentially, what they are, it's cache knowledge. That's fundamentally what a certificate is, and understanding how that works, and the cache invalidation is the certificate revocation problem, which, as we all know, is a hard problem to solve. Another way of looking at it is a digitally signed knowledge graph. So basically, each and every aspect of TAIBOM is describing the relationship between one component and another, but each of those arcs is actually being provided by potentially a different organisation, because it's a complex distributed problem. But fundamentally, as we'll see sort of like towards the end, the individual building blocks are actually very, very simple. So those are all sort of various definitions. I just wanted to seed your mind, because I think it will help you understand some of the detail that's to come. The other lens to look at through, which is probably the most important thing, is what are you actually going to use it for? So this is a sort of a very simplified list. This is the first four of these are sort of like the typical use cases of SBOM. And each and every one of these also applies to AI systems. So probably the first or the most common mention, but possibly not the most important use of SBOM, is simply security. Right? So going back to that risk aggregation problem I talked about earlier, we're trying to understand what is the risk, what's the inherent risk posed by the system by looking at the individual parts. And actually, when you dig into that at a level below, so what are the individual sort of like risky facets of the system that need aggregating? So in SBOM, the classic CVEs, it's a CVE aggregation problem. You're looking at vulnerabilities of the parts. So the vulnerabilities in the whole should be the sum of the vulnerabilities in the parts, or a subset thereof. When we add AI in, as we'll see, well, there's a new class of vulnerabilities coming in through the data that's being used, and the data poisoning. And those are what I call sort of like the negative security flags, the negative risks. These are bad things coming downstream. But we can also use the underlying system to forward push the positive indicators of risk. What things have you done to insulate yourself against these risks? Classic things being sort of like best practice. That second slide that I showed, all of those different initiatives, the vast number of those are just soft best practices. But if you can qualify that best practice has been used in one of the parts of your system, then you can propagate it forward into the end system. Other things would be penetration tests. There are a number of different individual strategies you can use to uptick or downtick the risk indicator, but the SBOM, the TAIBOM concept just allows us to propagate it across. But actually, if you're looking at SBOM, if you talk to CISA, who are sort of like the nominal sort of like primary protagonists of SBOM, it's actually what they call the FOCI problem is the big one: foreign ownership, control, or influence. So again, this is risk, but it's coarse-grained. Where the one above security, you're looking at minuet eyes of risk. You're basically tarring everyone with the same brush. So this is the Russian contributors to Linux kernel problem, right? But when you've got a big software system made of many, many parts, you need to be able to decompose those systems to be able to propagate those risks. But then the other one, so our friends from Fortescue talked about this at the Oxford thing. Licensing risk is massive. So we're moving away from security now. It's what's the danger of GPL pollution in your code? What's the danger of you accidentally including a piece of software with some quite stringent commercial considerations? People pay a lot of money to solve this problem. It's a massive existential risk to your company and product. SBOM, AIBOM is a method of helping you navigate this over a complex system. But however bad that problem is for the software, the minute we talk about AI systems and training data, we've got the copyright risk. And we just don't know how that's coming out yet. The legal cases haven't been done. There's lots of suing been going on. But the way you'll navigate it is by being able to traverse the dependency tree between the components. You've got another set of risks to do with support. I think this is only really just coming to the fore. Ian from Microchip over there can talk extensively on this particular topic. But the introduction of the new EU legislation basically means as a product owner, you are sort of responsible for keeping everything sort of updated and free of error. To be honest, if you're dependent on a complex set of open source, you've probably got no idea how complicated that network is. So SBOM, AIBOM gives you a tool to help you navigate that. And then the final one, which moves very much into sort of like what's nuanced and different about AI, is just what I call performance risk. It's sort of like you've trained something. It should operate at a particular critical level. If it's an autonomous car, that threshold is very important. So you want to be able to follow that, the risk, the positive tests, the negative tests in terms of how good it is, so you can see how it turns out in the final system. So I've got a lot of slides now, and they really talk about the 4 critical dimensions of what TAIBOM is really about, but it breaks down into 4 individual concepts. The identity problem. Have you seen this before? Is this thing the same as that thing? The dependency problem. So this is the thing is the sum of the parts. You know, what is your system dependent on, particularly through the lens of risk? The annotation problem, in terms of who's saying what about you. And then the final one is the inference problem, is sort of, you know, what can I infer from the final thing. So I'll talk mainly about the first 3, less about the fourth one. So, in one word, and this is why I keep banging on why I think TAIBOM is so foundational, it's solving the fundamental problem of what on earth are you talking about? You've just told me that you curated your AI data to a particular standard, or you trained your system to a particular standard. So what is it? How do I know I'm using the same thing you're talking about? In computer, science, it's a simple sort of like technical problem. It's to do with naming IDs. But unless you solve it, and unless you ensure that all of your other best practices make use of something, you've really got no idea what you're doing. The NIST cybersecurity framework, that first item on the right, identity, we've got to get that right. Right? That is just like ABC computer science. And it's asking myself sort of 3 simple questions. Am I using the same AI system that I used yesterday? If you're using ChatGPT, you really don't know. But you need a solution to that. You need to be able to point to something and say what it's and see what you're doing. Am I using the same thing you're using? Or is this thing the same thing as the thing you're talking about? So this is where the sort of annotations come in, because essentially a lot of what we're doing is writing descriptors about things, but I need to know my manifest. The thing that I'm talking about is exactly the same thing as the thing that I'm using. And that's in abstract. When it comes down to sort of specifics, we've just got 2 leaf nodes in the entire system. It's code and it's data. And these are solvable problems. They're certainly solvable if your system is at the edge, because the code is physically in front of you, so you can take a hash of it, and then you can make sure your descriptor is the same as the hash. And you can do exactly the same for data. So for edge-based AI systems, it's quite simple. For remote systems, things through sort of REST APIs, it becomes a little bit more complicated because you can't directly attest, you can't validate. So what you have to do is you basically have to use name and time. Specifically, it's that problem. ChatGPT, when I used it on the 24th of May, is it the same as the 25th of May? I don't know, really. Not with absolute certainty. I could take trust at a level of indirection, but if I want to label things so I know, I've just got to add the date of when I accessed it, and that has to become foundational. So that's the identity problem. So the dependency problem, what do you depend on? So just want to reiterate a problem I've already mentioned, but a lot of people get confused about it, and it's a very frequent critique I've heard of SBOM that I don't think is properly justified. There's a big difference between a recipe and a warning ingredient list, right? The recipe is listing the ingredients at enough level of detail such that you can actually build the system. And if you want to get really into binary verification, all that type of stuff, that's the type of thing that you need. This is not what SBOM's about. SBOM's really looking at the warnings. It's the classic, has this got nuts in, right? It's a coarse-grained method of understanding the material risks posed by your system. What should I be frightened of? And that's what we should be looking at. And so, in basic software, it's dead easy. You know, the X's are broken up by the individual components. You know, that is sort of, you know, this is well standardized. You know, it's enacted in law in the US and increasingly in the European legislation. It's sort of not now mandated. So, why are AI systems different? Now, there's an argument they're not. It's a level of continuum, because essentially what you've got a system here, a piece of binary, and it's got a behaviour. And what I'm worried about are what are the risks by that behaviour. Now, common or garden software is a shitload of functional code that's relatively locked and maybe a tiny bit of configuration data. That's sort of like how you know, if you download something and run it, it's going to look a little bit like that. AI just tends to invert it. Right? You've got a small bit of functional code that doesn't change very often. Your inference bit won't change, but the config data is totally driving the behaviour. It's data-driven behaviour, not functionally-driven behaviour. And it's not black or white. There's a continuum. There's loads of old-school software that also fits into this category. But when you understand that continuum, you have to describe your system slightly different in terms of understanding the risks. So just building up this concept of AI. So it looks exactly the same like the SBOM description, but we've added the weights in now. And the weights are huge. They can be huge on an LLM. But where do those weights come from? Well, they come from another XE. And where does that XE come from? They come from another piece of software. And the point being, any nastiness in any of these components can conceptually propagate right down to your inference system. And this is why AI systems are fundamentally more complicated in terms of describing the dependencies and therefore being able to follow the risks. And then, of course, the level above that, you've got the data on which it's trained. So this is where we get into data poisoning. So if you want to be able to track the impact of data poisoning over multiple versions of AI systems, unless you've got this, you've got no chance. And this is why it's sort of foundational. So risks run downhill. That's the fundamental sort of like concept that we're trying to get across. So we're just trying to describe what downhill looks like. We can't say it's guaranteed going to fall down, but we know if A is dependent on P, depends on C, then at least we have a model for doing this. And it does get more complicated. So I've just done the simple ones now. There's two extra sort of like key innovations that are needed, and these are possible additions to the TAIBOM spec. So in full LLMs AI, there's a whole concept of derived models. You know, training LLMs foundational models is very, very expensive. Increasingly, you can condense them, you can fine-tune them. But if there's flaws in your main system, the probability there's going to be flaws or risks in your derived system, so that needs to be modelled. And then the big ones are multi-agent systems. Because once you add multi-agent systems, take all that complexity, right, then chain together loads of AI systems. But that is the reality of the risk propagation that needs modelling. So annotations, this is the final sort of key pieces. So tell me about yourself. So what do we do with annotations? Because what I've done is I've just described so far the fundamentals of identity and the fundamentals of dependency. Well, authorship, who made this? Statement of conformance, did I use best practice when I made this? Whether it's curated the data or developed the training system or developed the inference system. Does it work well? The performance measure, this is critical. Did it break? Pen test. But then licensing, we can have software licenses, we can have data licenses. These are all instrumental. The way TAIBOM is designed, you can add whatever you want to this. We're not prescriptive about what you add to it, but obviously to follow to make use of the concept, whatever you annotate, there's got to be a propagation of risk or a propagation of the annotation downstream in the system. And the other foundational thing is who can say it. So the reality is, and this probably is the heart of the restriction that things like model cards, which is the other sort of like AI security feature, is they sort of presume the person that released the system knew everything. And the truth is they don't, not these days. It's just too big and too complicated. The person that curated the data, the organisation that curated the data, isn't probably the same that trained the system. It might have been fine-trained, and if you put it into a multi-agent system, it gets even more complicated. So one of the foundational concepts within TAIBOM is statements can be made by anyone. So when it comes to inferencing, what's the fundamental foundation? Well, anyone can say anything. Policy is subjective, and the logic's pluggable. Right? This is the distinction between trustable and trustworthy to some extent. By making something trustable, we've defined cryptographic primitives for making all of the statements that I just talked about. Whether you trust it or not will depend upon who do I trust. And even the logic, even the method of doing the logic, we don't mandate, because you can use very common or garden sort of like Boolean logic for propagating the risk, or you could start to get more statistical or probabilistic about it. That's up to you. That's as the end person. But the user of the system is always the person that should determine the policy. All we're trying to emphasise is the primitives. So what are the primitives? So the website, TAIBOM.org, it's all up there at the moment in its current draft form. Conceptually, I'm not going to talk about this in detail, but I'm happy to chat, coffee or take questions after. Everything I just talked about can be modelled in this very, very simple logical model. It's just breaking everything down into sort of like data, weights, dependencies, and attestations. Within there, we've got the full schemas. So everything that I talked about has got a full JSON schema behind it. Right? And I'm not going to say it's absolutely perfect, but it's our first good shot that's had a good number of internal reviews and some external reviews. But if there's any sort of like one big takeaway from today is please have a look, review, and give your feedback. But it's got all of the building blocks we think need to do it. And hopefully, when you put all those pieces together, you get back and address some of the primary challenges we talked about. So very specific, important questions can now be translated into a simple query. So, is there bias, poisoning, pollution in my training data? This becomes a query. I can traverse the net, right, and ask the question and propagate it through. Are there vulnerabilities in the code, or are there vulnerabilities in the data? Do I trust all the providers of all the systems? So this is the folky sort of thing that's coming from CISA. Has anything been tampered with? So this is just the standard integrity checks. Is performance good enough? Did you follow best practice? There's actually, these use cases are also formally defined in TAIBOM, but as I say, the key part, these aren't now just abstract wishes. This is a formal query that can be run against the technical claims made. So, hang on. Next steps. Join Gareth's wonderful new organisation. Be part of that. Review. So everything that I've just talked about is in the public domain. It's on an open source repo. Please give us your thoughts, feedback, positive or negative. Test. So there's some of the tooling's already there already for you to use, but you can also build your own tools to make use of the primitives. And finally, hopefully, and eventually implement. So, that is everything I've got for today.